we are going to graph exponential relationships. Now, we've done exponent laws, and we talked about the rules with exponent laws, where you've got if bases are the same and you're multiplying, you add the exponents. If bases are the same and you're dividing, you subtract the exponents. And if there's something raised to another exponent, you multiply the exponent. So we've done all those like exponent law business. And the reason we wanted to look at those is because we're now going to take our understanding of some of this stuff and start graphing it. All right. So looking at these four graphs here, they all represent exponential relationships. Some of them are growth and some of them are something called decay, but they all have certain aspects that are common. So if we look at those four graphs, I am going to tell you which one is what based on their colors. So the base graph that we want to look at is this one right here. This is considered our base graph for any exponential relationship. If we were doing linear, our base graph is y equals x. If we were doing quadratic, our base graph is y equals x squared. If we're doing exponential, our base graph is y equals 2 to the exponent x. The reason it is 2 to the exponent x is because 2 is the smallest number you can be with an exponent. You can't have 1 to the exponent of something because that'll just give you 1. So 2 is the smallest number smallest whole number you could put as a base that would actually make some different changes in our graph. So the base graph of a quadratic, if you look at it with blue, well, this is an important thing to notice. All of the graphs seem to converge right there. That's a very important point to notice. And then, as you can see, it stays above the x-axis, and then it goes a little bit more, a little bit more, a little bit. Now it starts to go aggressively quick. So this is called an growth or an increase. Because if we imagine we were walking from left to right, we'd be walking. Now we're scaling up a steep hill. So this is an increase. Okay. If we compare this equation, y equals 2x, to this equation, y equals 5x, you see they're both still increasing graphs, but if you look at the 2, it's kind of gradual versus the 5, it goes up really quickly. So the bigger the base, equals more steep. Okay. Then we've got these graphs that have a base that's a fraction. And this is like 2, this is 1 over 2, this is 5, and 1 over 5. We're going to look and see what happens with these relationships. So the 1 over 2 graph, I'm going to tell you right now, that is graph A. If I look at the value in the bottom, it's not as large as the value over here. So it means the graph is going to go up, but not as steeply as the other one. This is actually considered a decreasing graph because if you were walking from left to right, you'd be going down a hill really quick and then it graduals out. But if you compare that to this graph, it's not as steep. B is much more steep. Okay.